I was going to say we're going to restart, but the AV guy's gone, so like... Hello. Okay, we're going to restart again, so if everyone would like to take their seats, don't forget that, if you can grab people from outside, get them to come back in. Don't forget that we will be going on from this after 9 o'clock to the pub, so you can continue chatting then. Please come and take a seat.
I think most people are out there.
Yeah, I think we have to wait for a minute because everyone's gone out for another drink. Oh man, so silent now. Hey. Okay, good. Okay. Try and give people another 2 minutes to get in. So sorry about this.
It's fine. It's fine. No rush.
Come in.
My beer wasn't there anyway, so, you know.
Say again?
My beer wasn't there anyway.
Oh,
so,
okay. That's important.
Can't start before that. Just,
Come on in. We're going to get started again in a moment. Come in. Okay. How many more people are there outside? Okay, give people a big kick if you can. Okay. We'll wait 30 more seconds.
It's all good. It does seem like we lost a lot of people in the boat there still. It happens.
Okay, well, let's get going again. Thank you so much for coming back after the break. Our third speaker of the evening is Victor, so please, a round of applause.
Hello, everybody. My name is Victor Peterson. I'm going to deliver the last talk, which basically holds you hostage before the bar or the pub. So I'm going to try to not overrun this one. So I'm going to talk a little about something we call the DevSecOps iceberg tonight. And I'm going to talk a little bit what that means shortly. And it's essentially a way of thinking of the different attack vectors that you have in the application layers and the various layers that you interact with. So I will show you shortly how that looks like, but the outline is I'm going to talk about that, what it is, and then I'm going to talk a little bit of what you can do to prevent these various layers, and then finally go back and review the summary of that. So who am I? My name is Victor Peterson. You can find my Twitter in basically every other slide about this one. Entrepreneur, done a few startups. Prior to my current company, I did a digital signage company, secure digital signage using Raspberry Pis and open source technology, power over 10,000 displays around the world. And my current company is doing it called WoTT, and that's what I'm going to talk a little bit about today in today's talk. So without further ado, this is the DevSecOps iceberg. And the reason why this came to be was over the last year or so, Al, my co-founder over here, and I've been speaking to a lot of companies of various sizes and of various level of sophistication. And this is really an illustration of what we saw when we talked to these people. And real briefly, what we see is that a lot of companies tend to only focus on the very top, which is why it's an iceberg. They think about application dependencies and so on, but they tend to neglect the container level, which we have spoken about a bit tonight, which is great, but then we have the operating system layer below that. And a lot of people now, in particular in the whole cloud native world, have kind of moved so far up in the abstraction level, they almost forgot about the operating system itself and the hosts and why it's important to protect that. And the reality is really, if you can root the host box, any other protection you make doesn't really matter. If I can root that, you can have the best security layer, the application layer there is. Doesn't really matter. So that's why it's an iceberg. You have to think about all the layers in this in order to accomplish a reasonable security posture. So if you screw up one, it nullifies all the other efforts in the whole iceberg. So without going in too much into a vendor pitch here, so the company WoTT that I co-founded with Al over here, what we're doing is allowing people to simplify security in their actual host boxes. And I'll show you that a little bit. But we provide a cryptographic identity, so you can do fun things like MTLS and zero trust. We provide security audit with CV, more about that later. And we do workflow integration, and the idea is basically to gamify security. So I'll show you how that works in a little bit. But a lot of this talk here will be demo-driven. So the demo gods are hopefully kind to us. And the prerequisites for this talk is you have a GitHub account, which is kind of a given these days. And then we're going to use SNCC for the first layer, the application layer. We will use Aqua Microscanner for the next layer, and then we used WoTT for the third layer. And I've already created a GitHub repository that holds all this data. And it's basically a very simple Python app. I'll show you in a sec. And we will then use Circle CI for this. But the concept applies to any CI system you may use, so it's fairly straightforward. But in short, this is all we need to do in order to configure our Circle CI. So we've exposed our SNCC token and our Aqua token, which we'll then use in the build environment. And the application itself then is a simple Python app, which has dependencies, which is what we'll be focused on, and I'll tell you why in a second. But these are the assumptions that we'll make. It's a Python app with dependencies running inside of Docker on a Linux host, which we deploy daily-ish. And that's important for the reason that will be obvious in a little bit. So let's go into the first layer, the application layer. And we're going to limit the scope. This talk is by no means comprehensive for all things security, because that's a very long topic to cover. But I've broken this down into two sections. You have your code, and then we have your dependencies. So it doesn't really matter what language you're using. You're most likely using a lot of dependencies. So the talk will focus on the dependencies, not your code. The reason for that is that it's easier to standardize. There are tools out there that will help you with security audit on the code base itself, but it's not something that we cover today because it's too complicated to cover in this talk, and I have to limit the scope a little bit. So why does this matter? Well, the reason why most people pay attention to the application layer is that that is what is publicly exposed to most users. So that means that it's an obvious attack vector. And the problem is that as part of modern development flow, we rely extremely heavily on dependencies. And dependencies make your life a lot easier because they allow you to make faster development cycles, which is super great. However, it does add the new attack vector that a lot of people have neglected, which is if there is, for instance, a vulnerability in one of those dependencies or sub-dependencies that you're relying on. A good example for this is Event Stream, which is an NPM package that I think is pulled something like millions of times a day because it's used by a lot of other libraries. And this was in SNCC's developer report, by the way, if you want to read in more details about that, and I'll send the link in the doc here. And because it was part of the supply chain, it was sucked in about a lot of other dependencies as well. So you might inadvertently actually use this without knowing that you were using it because some of your dependencies were using it. So that's why it's really important to understand what dependencies you're using and auditing that on a continuous basis in order to find these issues. So do you trust your libraries? I mean, should you trust your libraries? Well, you should probably do some due diligence, and you shouldn't pull in any library from GitHub and just use it without doing some set of due diligence on it, right? Going forward here a little bit. So when do you run this audit check? So you can do it during development, which is obviously great. It doesn't hurt to do it. But you can use it during pull requests, which is something that SNCC Security Alerts, formerly known as the PandaBot, is doing. Or you can do it in CI, and that's what we're going to do today. So it's good. This is a good way if you're deploying often, by the way, which is I alluded to before. So there we go. These are the tools that we're talking about here, SNCC. There are others. I'm limiting the scope here. I'm going to go into demo. Sorry, I have to speed up a little bit. And all praise to demo gods, because now we are going to go into demo. And we're going to use SNCC as our scanner. We're going to use Circle CI, which I already got set up. And we're going to break that into dependency here. So nothing too fancy here. Just the regular Circle CI run. I'm going to show you real briefly how the code base looks like. real quick. So like you see here, we have a small little Python app. Actually, let me do this. Can everybody read this in the back, by the way? Yes. Awesome. So the app does really nothing. That's not really what we care. What we're really focusing on here is the dependency. So if we cat the requirements file here, I hope you people are familiar enough with Python to understand this part. You see that we have Flask, which is the main dependency for this. Now Flask, as you will become clear in a moment here, has a vulnerability in this particular version. So those not familiar with Circle CI might find this a little bit confusing, but I'll run this through really quick. Essentially, we have build steps here. So if you're familiar with any kind of CI system, you most likely understand this. In the first step, we just build an environment, which we have here. It just built a clean Docker image. I'm not going to zoom in too much on it's just a regular Python Docker image, essentially. And what I'll do next is add a new step to our, my keyboard is not working. All right, let's do it. For some reason, that didn't work. All right, so what we do now is that we can add a new step to our build environment that builds on top of our existing image and runs a sniff test. So let me show you. My Vim is not liking me today. Oh, it's the wrong window. Oh, sorry, guys. Oh, all right. That's why, I think. No? Okay. The demo guys are not kind today. Oh, there we go. What? Oh, sorry. I know why. International keyboards. Stupid. There we go. All right, so now I have to re-enable that because I forgot to save it. All right, so here we go. I'm going to re-enable this now. So does that make sense what I'm doing here? Basically, just running a file there. And then let me show you the snick file real quick. So it's basically sourcing the previous file. And then we add npm install, and we install so we can install snick, and then we run snick. So now that we've done this, I'm going to add this in. And now this should be picked up momentarily by Circle, and it's queued. Let's hope we are not unlucky with that. And the idea is now that once it's done, we will automatically run snick. So just taking a step back while we let this process here, the idea with this demo is that it should be applicable to most environments. I know you can zoom in a lot more. If you're in compliance business, you have to go a lot deeper than this. But this is basically for your average company, roughly what you probably should be doing as far as security. That's a minimum, bare minimum. So this is what we're doing here. And hopefully this, oh yeah, we're almost there. We got a slow build server, it looks like. And now, if we're lucky, it should be running. And after this has been installed, we should get a warning message here, and the CI should just stop it, which if you're building this properly within your build flow where you have CI/CD, it will prevent it from deploying, right? So any moment here, it should show you that, boom, snick runs test now, which then should throw us a warning. Oh, there we go. Yeah, build failed, great, which means that it detected the vulnerability that we had in Flask. So let's fix that real quick. Flask, I know we should probably use the version they're mentioning, but oops. All right, so install Flask, please. And then we're going to replace the requirements file. Up Flask. Oops, that was a typo, but that's okay. And now we should rerun, and we should have a clean run. But while we do that, I'm going to keep on going the demo, and I'll review that in a second. And that was the first layer that we take. Now we protect the application layer. Now we're going down to the container layer. And in the container layer, we have, again, two levels. You have the runtime environment, be Docker, be whatever it is. and you have the container. Your container is the one that includes your code base. It includes your CVs, off system packers in that container. If you're using Scratch, slightly different equation, but it could be a good idea, but it could also be a bad idea. We will focus on this part. And then we're going into runtime. It's kind of, if you're in compliance business, that's when you should really do more work around that. So why does this matter? Well, if you run root in a container, if you're running your application as root in a container, you might actually be worse off than if you're not using Docker at all, because there are escalation paths out, or there has been escalation paths out, and you would probably never run your service as root on your host box. So we kind of lost a lot of best practices there when you move to Docker. So there's some point there. There are some other good practices here in terms of vulnerabilities. If you're just pulling random images of Docker Hub, a lot of them can actually have vulnerabilities in it. So we should actually have a frequent check of the dependencies in these images, right? So if you're using, like Chris said, if you use Scratch, that could be a good mitigation strategy for dependencies in the operating system, but it comes at a price, as clearly pointed out. Where do we run this? We run it on CI. This is what we do in this case. If you have long-living images, then you might want to run it on container registry, because that is really when, if you have been running things some more longer time, you might want to put it in there instead, because it will allow you to scan for existing images, not just when you release. These are the tools that we can use for this. So we use Aqua Microscanner, and then we use Cisco Falco and other things there. I'll put these decks up afterwards, so don't worry about it. I'll tweet them out, so I guess Cheryl can retweet that later with all that, so people can do that. Getting a bit into the next demo here, and hopefully that will go smoother. So as we see here, let's go check back on this guy. Boom, now it's successful. So we fixed the vulnerability, great. So Snyk did its job, detected the issue, and we solved the issue as well. So if we now go into the next step, and since I already prepared this GitHub repo, by the way, is already available there as well in the slides, so I'll share that afterwards. If we now want to run Snyk, if we now want to run Aqua, let's see, we have this. So is that still, crap guys, sorry. Can you guys read that still? Yes. Yeah. Good. So what we do is essentially the same thing as we did with Snyk, but we're running Aqua on the image. And Aqua will do a scan on the CVs inside the Docker image. So let me save that and show you the Aqua file. There we go. Oh, that was the Snyk one. It's essentially the same thing. It's scanning. The one thing worth noting here is that we do continue on failure, which you may or may not want to do, which means that it will actually pass even if it finds a vulnerability. And I'll show you why in a second. But Aqua, and now we're going to run that in here, and that should be picked up here any moment. It is already queued. Cool. So while we wait for that to run, I'll skip forward to the next part, so which is the operating system layer. And the operating system, as I mentioned, is, I would say, one of the things that people actually neglect these days. It used to be common practice, but we can't neglect to do CV scans and vulnerability scan on these VMs these days. And this is out of scope, said no attacker ever. Basically, like if you have vulnerability, well, an attacker doesn't give a shit if it's in scope or not, right? So we need to think about this entirely, like holistically. Oops. And we need to cover a little bit pet versus kettle. I think everybody's most aware of that by now, how that works. Long-lived versus short-lived servers, real briefly. And one thing that we found when we talked to customers that a lot, in particular mid-sized companies, they tend to misunderstand what the cloud vendors will do for you. A lot of them are under the impression that cloud vendors will patch your VMs. They won't, unless it's a managed service. So that's a big important distinction here. And why does this matter? Well, root and host equals game over. So that's why it matters. If you can compromise the lower level in the iceberg, you game over. And remember Heartbleed, Spectre, and Meltdown? Well, these were all operating system vulnerabilities. And they could be actually used higher up in the food chain, right? So you can actually compromise them using the application layer. So think about these things, and that's why it's important. And think also, again, out of scope, think about things that are on the network that can be attacked from another node if you can access one. So that's where the whole zero trust philosophy comes from. And assume everything is public and configure things accordingly. That's probably the best learning experience that you can do when you configure your hosts. So that is it for that. And when to run that? Well, you kind of need to run it continuously, because that's kind of the only way to do it, because you don't have a nice fit into the CI/CD pipeline. It's something that happens like continuously on the host. Some tools, you have our tool, WoTT, which I'll show you in a second. We have Red Hat Satellite and a few others that can do the same thing. Again, I'll share that in the deck. And we'll now pop over to a demo again, and this will be slightly different. So, before we do that though, let's go back here. We now have a successful run. Well, like I said, we disable the failing exit on failure, right? So actually, if you look at the logs, we can actually see that it did detect a bunch of vulnerabilities in our Docker image as part of the runtime. If you want to be really strict, we can tell it to quit and make the CI run fail if it detects it. But we decided to not do that because a lot of these vulnerabilities have not even been fixed upstream, or they're not relevant. So you would have a lot of false positives. So if you want to be strict, you enable that. If not, you audit it. So that's really up to you how you want to do that. Now, let's go back to the other demo. So let me see. I'll hop in here right quick. I've created a simple server, a Google Cloud instance that we have here that I created earlier today. And what I'll show you now is how to install the WoTT agent, which will give you security audit. So if I go to the WoTT dashboard, dash.wott.io, click Add Node, and I copy that string, and then I paste it in here. That would install, and here you can see it will install the agent. It shouldn't take too long, but the important thing here is that the agent does an assessment of the state of the device and reports it upstream so we can get understanding of what's going on in the system. So in a few moments here, when it's done the first run, I'll be able to see what it detected. And it will do more advanced things like trust scoring and things like that, but I'm not going to go into that today in this demo. But there we go. Now the agent has been installed. It has been claimed to our account. So if I reload this, I should be able to see our server. Here it is. And if I go here, I can see we actually detected three CVs in that server that we just created. So that's how you can monitor this. But that's one of the elements of server security. The other one is poorly configured services. So if I go up here to recommended actions, we actually found a whole lot of things, right? We found that there was no root password set of MySQL. We found that the MySQL is public exposed. We found vulnerable packages we already talked about, as well as insecure OpenSSH configuration. These are all things that an attacker could use to exploit your system. So if you get in there, well, none of the other layers matter. And that's kind of the whole point of the iceberg. If you can penetrate that level, nothing else matters. So that was a very, very fast run of that. So to summarize, understand your threat model. Depending on what industry you're in, it will matter significantly. In banking, you're obviously very different than if you're like a small startup doing, I don't know, consumer mobile apps, whatever. You need to secure all the layers in the iceberg. It's super important that you don't skip that, because if you do, you kind of shoot yourself in the foot. And understand that different layers have different attack vectors. So, and I have a reference here that you guys, well, you can't really copy from here, but I will tweet it out and you will see the deck there. And the demo guides were actually rather nice today, so it was just my keyboard that was messed up. I can't really blame that on the demo guides. So, do we have a few moments for questions? How are we doing? Cool. Or if there are any, that is.
Questions?
Hey.
You mentioned earlier that WoTT can function as an IDS.
Not quite an IDS. It detects some configuration. It's not quite an IDS though. It's not like the snorts or something like that. It's not really at par with that. Although it's something that we are toying potential with in the future, but not currently.
think there was one back here.
People really went to the pub, huh?
No.
Yeah, hi. I have got a hobby project of mine, and I'm looking for building a CI pipeline for it, and I'm looking for some open source things which I can include in that for the vulnerabilities and the Docker images as well. So, any recommendations around that?
For CAs?
No, CI, like a continuous integration
Oh,
pipeline.
CI/CD. Well, I mean,
I want to include these steps as well.
I mean, I'm a big fan of Circle. I think that's a good CI. Like you mentioned before, Google has their own cloud runner now that some people tend to like. I mean, otherwise there's Travis. There are so many of them. Depends what you're looking for. If you want something simple, Travis.
I asked for the recommendation for the vulnerability detection actually. So if I wanted to include a step which will say check my code vulnerability dependencies and for Docker image vulnerabilities as well. Mm-hmm. I was working in a bank where they had something called Kraken. I don't know if anything exists.
Yes,
so it was checking the vulnerabilities before. So once my image has been pushed into the hub, and then before deploying it to the containers, it will check the vulnerabilities.
Yeah.
If it's any, the build will fail and it will not deploy.
Yeah.
So any such recommendation do you have for the open source one for my hobby project?
Yeah, so Corvus Claire does this. It's a bit of a mess to set up. Docker Hub used to do this, but I think they sunsetted that feature. But there are, I think Snyk is toying with that as well. I think Snyk is actually shipping something similar as well. But I think there are quite a few on the market these days, actually. I haven't honestly kept up super well with what the latest ones are there. I think Snyk is probably the latest one to do it. But Aqua got some as well, so there are quite a few of them, yeah.
Okay, thank you.
Cool.
Cool.
I think that is it. So round of applause, please, for Victor.
Awesome.
All right, and that concludes our evening. Thank you so much for coming out. We'll be back here again on the 5th of February, so I will see you all then. And we're going to go up to the pub, so if you want to come out, we'll be going that way in a few minutes. Thank you.